So we are still working our composition of functions, and so what we're going to do is review what composition of functions are in the context of problem 18. Now, 2 days ago in class we talked about what a composition of functions is, and what you do is if we want to have f of g of x, what that means is we take this one here that's closest to the g and we insert that, so we run an input through this function, and then after we have an output, what does the output do? Goes to the other function, and then has an output here. And so we call that f of g of x. And in this case, what we have is we put this one inside of here. We're going to have f of g of x is going to be equal to this square root of x in the place of this x. So that's going to be 1 over square root of x minus 1. Can this be simplified any further?
I'm lost.
No, we can't simplify this any further. So all we did is we took this thing right here. Okay, do you see this format here, y over 1? Y equals 1 over x minus 1. All you did is you kept the basic form of this, but you took this and you placed it right here. So all this thing is here, it's this thing, but with this square root of x replacing that x. Okay? So it's the same form, except this square root thing replaces that x here, and this is what we have. Okay? Now, so we're going to save this and put this on problem 18 for a problem. Yes, you have a question? This is our answer, but we don't have the domain worked out yet. We'll work out the domain, but this is the answer for f of g of x right here. Okay, now g of f of x is going to be what? Well, we take this f of x function and place it where? Inside this, right?
Yep.
So we're going to take this thing right here and go right over here and replace that x right there. So what we're going to have is square root of this thing right here. Now, can this thing be simplified any further? No, it can't. Okay. Now, what is the only thing we haven't done yet on problem? We haven't done the domain, right? So let's talk about the restrictions to the domain here. So in this square root of x, what is the restriction that has to do with square root? Okay, no negatives, right? Very good. And how do we go ahead and make an inequality that says no negatives? Greater than or equal to 0, right? So that's going to be our restriction. And this restriction we put in over here. So that restriction still is valid for this thing here. For this thing here, right? Because we took this over here, right?
Yes.
Do we have any other new restrictions here? Well, we know that x squared minus 1, square root of x minus 1 cannot equal 0 too, right? So in this case, a square root of x cannot equal 1. And so what can x not equal? X cannot equal 1. So we know x has to be greater than or equal to 0 but also that x cannot equal 1. So what does our domain look like for that?
Bracket 0.
So we start out, so bracket 0, does that look right? To 1, parentheses, 1 to infinity. Now what I've noticed on these problems here, so here's our domain, is most of the time, the hard thing is not finding the composition of functions, but finding rather the domain, right? Because this part wasn't hard at all, right? All we did is we just replaced the square root into here. And now for this one, what restrictions do we have for this one? We know x cannot be 1, right? Same thing. X cannot be 1. And we know that this whole thing has to be greater than or equal to 1, right? So 1 over x minus 1 has to be greater than or equal to 1. And where does that happen? Because this thing, for it to be greater than or equal to 1, this thing has to be what? Has to be, is it less than 1? How do we figure that out? Oh, hang on, see, I said it wrong.
Greater than 1?
Greater or equal to 0, right? Yeah, I said it wrong. So now, this thing has to be, this has to be positive, right?
Yeah.
So that means x minus 1 has to be greater than or equal to 0, because that's going to happen. So x has to be greater than or equal to 1, which is what we had already. Or we had this. So x has to be greater than or equal to 1. So what's our domain for that going to be? 1, comma infinity. So that should be our domain for this guy here. So this is 18, all worked out here with the function machine, okay?
I have a question.
What's your question?
Are we going to start doing our stuff on our Chromebooks?
Do you have your Chromebook now?
Yes.
Well, the thing is, you'll be set up to do it on your Chromebooks, but most, like the assignments we have, are really set up on paper, meaning that the paper is available, and what they do is the remote learners will get those assignments, and they will take pictures of the work they do and submit those pictures to me via Canvas, or they'll just email those files straight to me. And so really the way at least this classroom is set up is more as an outreach to the remote learners than it is changing for what we normally do in a classroom. Now I can't say that's always going to be the case, but that's kind of the way it is for now. Does that make sense? Okay. But we'll have to see if all of us become remote learners at some point. We don't know. Hope that doesn't happen. And it's really helpful, Kinsey, it's really helpful that you didn't come down with the virus this time. Thank you for helping us. All right. So I want you to go do 19, and then we'll talk about it. So spend a few minutes working on it. Did you already work 19? Did you already work problem 19? So work problem 19, please. Again, yeah, work it right now. Again, and don't even bother with the domain at first. We'll clean up the domain later. Work it without the domain, okay? And then we'll clean up the domain afterwards. How's that? Can you do that? Okay. Somebody, could you tell me what you got for f of g of x?
I got 1 minus x squared.
Okay. Are we okay on that? That's like the final answer of that, but we know how we got that, right?
Because the square root and the square cancel out.
So what happens is this square root thing goes and replaces this x, and then the x squared and square root cancel each other out, and you're just left with this.
That makes a lot of sense.
Makes a little more sense? Okay, good. And then for this other one, g of f of x,
I think it's the same thing.
Yeah, is it good? No, because
Or it's square root of 1 minus x to the 4th.
yeah, you should get this.
No?
You should get this. Does that make sense?
Yeah.
because it's still inside the square
Yeah.
root.
So what you've done for g of f of x, you've taken this thing here, and you've replaced this x here, and then you square that, so this x squared squared becomes x to the 4th power. Yes?
Could you also have 1 squared and then outside of it minus x squared?
1 squared minus x squared here.
Look, come here, like this. So only the one.
Well, square root of 1, which is 1. Is that 4? Oh, so you broke it up? No, you can't break it up because it's all in that. You can't do that. Yeah. Well, that's good to know. That's a good question. Yeah, you try to simplify where you can, but when you have two terms like that inside the radical, you can't separate it out there. Okay. Okay. Now, what about our domain restrictions on this? Okay. So this is going to be, our restriction is going to be based on this, right? So 1 minus x squared has to be greater than or equal to 0, right? And so if we solve this inequality and we add x squared to both sides, 1 is greater than or equal to x squared, right? Or alternatively, x squared is less than or equal to 1. Or, yeah. Is that right?
So it's just,
So we have x. X is going to be less than or equal to 1, and what else? X is greater than or equal to negative 1.
yeah.
So for this, our domain is going to be what? Negative 1 to 1. And the only thing one thing you can do is you can take, well, it's based on the restriction here. It's really based on this restriction right here, right? So square root of 1 minus x squared, what does that look like? Square root of 1 minus x squared. See what the thing looks like? So we get this little thing here. And we saw this earlier when we were working on another related thing, weren't we? Yeah, and then, so function is defined between negative 1 and 1. That's it. Okay? Does that make sense? again, I think finding the domain of these things is a lot more challenging than just, because there's not a whole lot of simplifying to do on most of these.
I think the domain is hard as well.
Yeah, it is. But it's good, but following this is good for this level of class because that's where you become more mathematically critical thinkers by doing this. Okay, now for number 20, yeah, I'll show you that in a minute, but I want to ask a concept question. Are there any restrictions to the domain here? No? Anybody else? Kinsey says no. Anybody else?
I don't really know how to tell by just looking at it.
Okay, well, we'll tell you. Okay, I'm just asking you to give your opinion now, and then I will tell you in a minute. That's good. That's good. Kinsey says no. Anybody else? No, anybody else have any ideas? Do you think there is a restriction or not? You think there is not or is?
I say yes.
You think there is a restriction?
Someone's got to say no, so I'll keep my mouth.
Okay.
Ouch.
Well, actually, this is one of those situations where there are no restrictions. Why are there no restrictions here?
As Kinsey said, no.
Because Kinsey said no.
Is the cube root and the cube cancel out?
Well, no.
Kinsey.
No, the reason is that you can have the cube root of a negative number, right?
Yeah.
And what I want to do is I want to give you an example here. Okay? Here in red, this is the square root function, right? Y equals square root of x. But what does the cube root function look like? When we did notes, that's one of the reasons I had you do that. Remember the notes I had you take? Okay, here's the cube root function, like this. All right? So this one here is y equals cube root of x. Do you see that there aren't any restrictions to this blue one here? But there are to this, and so therefore there are no restrictions. If there are no restrictions, it makes the thing pretty easy. Now, Angel, you were asking about how do you do this in a calculator? What I want you to do is, if you have a g of f of x, that's going to be cube root of 1 minus x to the 9th power. Is that what you got? Okay. So I'm going to put this in a calculator to just see what it looks like. Okay? And Angel wants to know anybody else. So 1 over, so cube root, right? Okay, what you have is that you can go to math. There are different ways to do it. But you go to math. You can either use 4 or 5. 4 is like the pre-programmed cube root, or you go to 5 and just put a 3 in the place of x. So I'm going to go down here to option 4, and it already gives me the cube root. So now I can put in 1 minus x, was it x to the 9th power? And we can graph the thing, see what it looks like. And that's a really sharp looking thing here, but remember there should be no domain restrictions, right? And if we go to table view, should we see any breaks? I mean, that looks like a break here at 1, right? But there really shouldn't be any breaks. Well, there aren't, are there? So this is going to be our answer for g of f of x. And our domain is going to be this thing here. And then, what is the other one going to be? Well, it's going to be f of g of x is going to be what?
1 minus x cubed.
1 minus x cubed. And again for this one, our domain is going to be okay. Good.
Please do not do that.
What we're going to do is I'm planning at beginning of class tomorrow, we're going to have a quiz on compositions. And it's going to be an easy version of these things here, where you could just, I'm not going to ask you to find the domain and stuff like that, even though you could with a calculator. Yes, you have a question?
Can I put absent?
You can put absent, but better yet, what you should do is you should go and look at the text message I sent you with the video from yesterday's class, right?
Yep.
Because I sent one out, it was a little after 5 o'clock yesterday, didn't I?
Yeah.
So that'd be the best way to do it.
Or mine.
The 21 isn't the same for both?
For this one here,
21.
oh, 21, hang on. You're on the 21 now. Okay, just
Can
go
I
to 20.
play a Kahoot game?
Not today, I don't have one ready today. That might be a good game tomorrow. That might be a good thing tomorrow.
What's it?
We have a quiz tomorrow?
Yes.
It just said.
Now, so Angel, you've worked this one out, right?
Yeah, that seems the same.
Yeah, kind of.
Now let's see if it is. Okay, we know that x cannot equal what?
X
One equals.
Cannot equal 0. So that probably is our only domain restriction here. I mean, as far as we can see now, right?
Yeah.
So f of g of x is going to be plugging this into that, right? So we get 1 over 2, and then we have 1 over 3x, right? Is that right? Which is going to be 1 over 2 over 3x. Now what does this simplify to here?
6. Oh, wait, no.
0.5 over 3x.
What'd you say?
0.5 over 3x.
0.5 over 3x?
Or would it just be 2 over 3x?
I'm going to go ahead, no, it's not going to be that. Let me give you a principle. Okay, this is back to 7th grade math or whenever you learn this. Dividing by a fraction is the same as multiplying by the reciprocal. So what I want you to do is multiply that 1 by the reciprocal of 2 over 3x. And then what do you get when you do that?
Maybe over
3x over 2 is what you'll get. Okay. So this will be your answer. F of g of x is equal to 3x over 2. And then also we have for our domain, how do we write our domain? Right? So there we have that in our domain. So try to do g of f of x, see if you get the same
I
thing.
think it's the opposite.
Now g of f of x, you should get 2x over 3. Is that what you got? So see if you can figure out how to get 2x over 3. And if you do that, that'll be good enough for this one. And then our domain. Yeah, I'm going to see if I can find a good Kahoot game for compositions, because that would be good to have tomorrow in part for class. Especially on Friday when I got to give you that baseline test thingy. Okay, and domain, same, right? And then this one here. And then we have this one, and that's it. So you can just finish that up, and that's gonna pretty well get us to, for class today. Maybe we finish class a little early.
You
Let's
want us
see.
to do 22?
Yeah, do 22. That'll put us to a good point. For 21, I think it was everything except 0, because you can't divide by 0.
Mr. Judy, when you have
Yes,
ones like on top and bottom of the fraction, do they cancel out? Or no?
in this case here, really we can't, because you got to look at that x plus 1 as a totality. So you really can't do that unless you have a 1 isolated. Now, if there's 1 multiplied by x, yeah. But added to or with addition or subtraction, you can't do that. What I'm going to do for this one here, for 22, I'm going to write down the answers and see, you can check yourself on this thing.
I don't know how to simplify it.
Well, I'm going to give you the answer here. Okay. And see if this is what you got. Okay, f of g of x is equal to, right in here, x minus 1 over x. Is that what you got? Okay. And also domain's going to be x cannot equal 0 or x cannot equal 1.
Where did the other x come from?
Where did it come from? Okay, well, that's a question of how to work this out, so let's do that. Well, we have f of g of x is equal to 1 over x minus 1, and then we have this plus 1 here, right? So this replaced this, and so what we're going to do is deal with this thing right here. So our common denominator is going to be x minus 1. So what that's going to be is 1 over x minus 1. And this thing here becomes x minus 1 over x minus 1. Do you see that?
Equals 1 because it's the same.
And then what you'll have is when you add all this together, you're going to get 1. And this 1 plus x minus x just becomes x. So we have x over x minus 1. And then when we multiply this by the reciprocal, what do we get? This thing here.
Okay. So
Okay?
you just have to find the common denominator
Yeah.
and then make that 1.
Yeah. Okay. And out of confession, I didn't work this out until you asked me to do that, but I got the answer from the book. And then for the other one, let's see, it's 22. You should get X plus 1 over X. Except when you want to. Oops, wrong one. And then this is what you should get for g of f of x. Is that what you got?
Yeah, it's just the opposite, but
Kind of the opposite. Okay, good. Well, I'm glad you did. I'm glad you really questioned me on this last one here, because this is a good little piece of algebra that I appreciate Emily and anybody else who challenged me on this.
Mr. G.
Yes, ma'am.
He needs to go to the restaurant.
Okay. Well,